Okay, so here's the plan for today. Alright. We are going to take a region. Okay, so pretend like that's your region. Let me zoom out here. Okay, you see that's like a normal XY plane, right? You have like, this is x squared. If I slide up over here, you can't actually see that. Okay, but your equation is 1/2 x squared, yeah? Okay, so what's going to happen today is that we are going to rotate this around the, oh, it didn't work. Hold on. Computers. Okay, now let's try it again. Nope. Hold on, we'll use this thing. Okay. Ooh, look at it go. What's it doing? It's rotating around the x-axis, and then it's making like a cone. Okay, now let me see if I can like move it around. Oh, no, I can't. Okay, you get it? That looks horrible. Hold on. Let me see if this helps. Okay, now let's say I wanted to do a different shape. Oh wait, hold on. View. What does this do? Never mind. Okay, let's try now a different shape. Okay, just track with me here for a second so you can visualize what we're doing. Oh, I can't see my.
She betrayed you.
What did you betray me in? Okay, listen. Okay, can y'all see this? Yes? You don't seem very interested. Okay, look. Okay, we'll make it x plus 1. Okay, do you see your little region? Now look, this time I'm going to make it from 0 to only, let's say, 2, so it's a little bit smaller. Okay, you see your little shaded region? And then what's going to happen is we're going to rotate it around the x-axis and create a 3-dimensional solid. Okay, now imagine if we, remember it was rotated, if we cut through the middle, what shape would you see if you opened it up? If it was rotated? A circle. Great. Okay, so let's go to your notes. Okay, and we are going to find the volume of these solids. Okay, it's pretty easy. So this is the last week of new stuff, and then we review starting on Monday.
Yeah, you did say that you would know.
Well, this is still volume, so I meant like all of the volumes together. Okay, pi integral r squared dx from A to B. Okay, now let's talk about a couple of things. You are going to use this method typically when you're revolving around the x-axis or any other horizontal axis of rotation. If you read that right there, I'll highlight it for you. This is if you're going around the x-axis or any other horizontal axis. Now, A and B are going to be x values. And when you draw this, which we will practice here in a minute, your radius is going to be top minus bottom. Okay? So the plan for today is we're going to practice this dx and dy since I don't see you tomorrow. So we're going to try to just do it all in one day. And then tomorrow in the lecture hall, you can just do your homework, because I know you will want something to work on. Okay, ready? Look at your equation. Y equals square root x. What's it look like? Yep. There it is. Y equals square root x. My next shape is the vertical line x equals 4. And then it says also, it lists the x-axis as a side. So can you see where we're shading? Right here. Yeah? Okay, here's the plan. Remember the little video I showed you. We're going to take that shape, we're going to spin it around the x-axis, and if you can kind of picture it, like about what shape would it make? Think about it. If this flipped over like that, okay, it'd be kind of like, it's called a nose cone, because it's not pointy, it's kind of curved on the end. My other class said it looks like a bullet. Sure. Okay, that'll work. Okay, but you're rotating it around and you're making a cone with kind of like a rounded edge, okay? Now, draw for me, please, the radius of that circle when you spun it around. Your radius would be drawn in right here, from top to bottom. Okay, can you see that from here to here, that's running up and down, and if you spun it around and slice the shape to look at the inside, that would be your radius from there to there. Okay, so the radius is going to be top minus bottom. What's the function on top? Y equals square root x minus, what's the bottom? That would be y equals 0. Now, do you have to put the 0? No, you don't. Okay, but just to illustrate, this is the top of the radius. This is the bottom of the radius. Okay? And then remember, how do you find volume? You do pi r squared. So it's going to be volume equals pi r squared, where my r is what? Square root x. Now, my a to b have to be x values. So where did my region start on the x-axis? X equals 0, and when did it stop?
4.
0 to 4. Good. Make sense?
Yep.
Alright, from there, what is the square root of x squared?
X.
So that'd be really just the integral 0 to 4 of x dx. Okay, and I did not write a dx here, but I'm writing it in now. And then what's the integral of x? 1/2 x squared I'm going to put in the box, but the half I'm going to bring out with the pi. And then we're plugging in 4 and 0. Why did we not change any endpoints? Because it's not used up. Very good. 4 squared is 16. 0 squared is 0. 16 minus 0 is 16. Cut it in half.
2.
8. Yeah. So divide by 2, you'd get 8. And then pi is still there, so it'd be 8 pi. And remember, what does that represent? That represents the volume of that bullet shape when you spin that around. Make sense?
Yes.
Love it? Okay, another one. Y equals 2x plus 3. Graph it. 3 is here. 2 is uphill. There's our graph. Then we want the x-axis, and x equals 5 would be here. Okay, when I shade, read carefully, should I shade all the way to this x-intercept and do that whole big triangle?
Yes.
Okay, the answer is no, you shouldn't. Read it.
X.
Right here, look. What quadrant?
Third.
That means you can't start shading until 0. Okay, so watch out for those kinds of things. If it says first quadrant, you're not going to start shading until 0. Okay, now picture, if I took that shape, what does it say I'm revolving around? Rotate around the x-axis. That means I'm going this way. Yeah? So I would be bringing this around and around and around. What kind of shape would it make? Yeah, kind of like a cone, but the top got cut off. So it's like flat on the top. Okay? Now, if you have trouble visualizing them, that's fine. All that you have to be able to do is draw in your radius. So if this is my cross section, which is a circle, the radius would be from here to here. Is that radius drawn right minus left or top minus bottom? Top minus bottom. So my r of x would be the top function, which is what? 2x plus 3 minus 0. Because 0 is the bottom where that radius hits, right here. Does that make sense? Okay, set up your integral for me. Volume equals pi on the outside. Where am I integrating from? 0 to 5. And then your radius would be 2x plus 3 squared dx. Okay, we are not going to do most of these integrals, but we are going to do this one. What's your u? Okay, your u would be 2x plus 3. What does that make your du? 2 dx, which means that dx is du over 2, yeah? Okay, du over 2, I'm going to put my over 2 out front with the pi. And then I have the integral now of u squared du. then what do I have to remember to do at those endpoints? Change them. Remember, you're plugging into 2x plus 3. If I plug in 5, what's 5 times 2? Plus 3? 13. Plug in 0, 2 times 0 is, plus 3 is 3. Then from there I have to take the antiderivative. It's u squared. What's the antiderivative of that? Okay, so I have pi halves 1/3 u cubed. And then remember, if it's only one term, I'm going to cut that 1/3 out of the box. If there were multiple terms, you couldn't do that. But if it's just the one thing, you're allowed to do that. Then I'd plug in 13, then I'd plug in 3, and then I'd subtract. Now, you don't know what 13 cubed is, I don't know what 13 cubed is, so we're just going to write 13 cubed. So your final answer would be 13 cubed minus 3 cubed we can do, 27. And then what would be on the outside? Pi 6. And remember, that would be the volume of that solid created by rotating that region around the x-axis.
How come this one was easier than
You thought this one was easier? Because it was the second one, maybe. I don't know. Or because it had u sub, yeah. Okay, we got 2 more dx's, and then we're going to switch to dy. So look at the next one. X squared plus 4, what's that? Parabola, but where is it shifted? Up 4. So there's our parabola. And notice it says I'm bounded above by x squared plus 4, and I'm going to be bounded below by y equals 4. That would be here. Okay, now question. Those cross once, right? They cross here. Do they cross again to tell me where to stop? No. How does it tell you where to stop, though? Yeah, keep reading right here. What does it say? On the interval from 0 to 2. So I would start shading here at 0. I would keep shading until 2. And then I would stop at that point. So I'm going to put right here. That's x equals 2. This is x equals 0. So far, so good? Okay, reflect that region over what you're rotating around. Now, read carefully. What does it say I'm rotating around? Find the volume of the solid generated by rotating r, that's this, around y equals 4. That means this is going to be the center of your solid. So when I flip that over, it's going to go kind of like this. Can y'all picture that? Okay, it'd be kind of like a volcano, but sideways. Like a little slanty volcano, kind of pointy on the end, yeah? Okay, draw in your cross section. When I say cross section, I mean like if you cut it, what shape would you see? You would see a circle. And then I'm going to draw in my radius right there. Okay? And then from there, how does my radius run? Right to left or top minus bottom? Okay, what's the top function that I'm touching right here? X squared plus 4. And what's the bottom function that I'm touching? 4. Okay, so the top is what the top of your radius line is touching. That would be this. And then the bottom is this. Now, what's going to happen with the force? They're going to do what? Cancel. Good. So if it's 4 minus 4, those go away. And my radius is just really going to be x squared. Okay, then from there, how do you find the volume? You're going to integrate pi r squared, where this is your r. Where am I going to integrate from? 0 till 2. And then it's going to be x squared squared dx. Questions about that? Good so far? Okay, alright, we have one more dx, then we're switching to dy. This is a semicircle, and it's the top of a semicircle. Now remember, on the AP test, they're going to give you pictures, or they'll give you a calculator, or it'll be an easy equation. Okay, but this is a semicircle. Look at the equation. Take a guess what the radius is. That's a 9. Your radius is going to be 3. So 3, 3. Now, am I necessarily going to shade the whole semicircle? No. Read carefully. And actually, hold on. Bounded below by, we have to draw this other line. -1 would be here. Okay, do those graphs ever intersect? No, but they're going to tell you where to shade. Where are we going to shade from? -2 to 2. So that means I'm going to start shading here. I'm going to stop shading here. So I'm not doing the actual entire semicircle. I'm starting and stopping before I get to those ends.
How do you know that was the semicircle?
I just happen to know that, and I made the question. But on the AP test, they wouldn't give you one that hard. Okay? And do you remember we used to, like, we'd square both sides and then add the x squared over? So it'd be x squared plus y squared is 9. And then that's how you would know it's centered at 0, 0, and your radius is 3. Okay, but that's like pre-cal stuff, so you probably won't need that for the AP test. Okay, so take a look at your picture. Reflect it across. What's the line we're rotating around, it says? Rotating region R around the line. Y equals -1. This is -1. So if I rotate around that, the other half of my circle is going to be down here. And then remember, any place that I cut it, okay, it's kind of three-dimensional, but you'd almost have like a bead where the sides are cut off, but it'd be kind of round, or like a donut maybe, right? Okay, but it'd be going around in a circle, so it'd give you this solid shape that's round on the edges, but flat on one side, flat on the other side. Okay, draw in your radius. This is the first one we've done that is not revolving totally around its own self. Okay, so when I do my radius, what is the function on the top? 9 minus x squared. Now I'm doing the top half of the radius here. So this is my radius right here. Okay, and then what's on the bottom? What's on the bottom of the radius? -1. Okay, now, I'm going to come up here and try to point at stuff. Why would it make sense that minus -1 would be the other part? Because if this is my y value, what do I need to do to get my radius? Add one more, right? However long this is, I'm going to add one more to get to the center of my shape. Does that kind of make sense? If it doesn't, though, don't stress. Top minus bottom. What's on top? This guy. What's on bottom? This guy. Okay? And then how do we set up our integral? Volume equals?
No, -1.
Okay, so pi integral negative, wasn't it -2 to 2, yeah? And then my radius would be this chunk right here, but I'm going to change that minus and negative to a plus. So 9 minus x squared plus 1
So that's going to be outside the radical.
dx. The plus 1 would be outside of the radical, correct. Make sense? Okay, Emily, did you drop something or are you frustrated?
I just dropped it.
Okay. But not out of anger? Okay. Do you want to do maybe 1 or 2 off your homework to make sure you got it, or do y'all feel like you're... Okay. Why don't y'all set up, get out your homework. I didn't grab one. Do number 5 and 4. 5 and 4. 4 and 5.
I have one.
Anybody need one? Okay, number 4 and 5, and all you're doing is setting them up. Okay? 4 and 5.
What is the little box on the inside where it's rotating?
That would be kind of like your radius, but it's rotating around the x-axis every time. Hey y'all, if you look in the instructions, all of these are going around the x-axis. It says it right here. Okay, so this is your x-axis. So flip it across. Oh, okay. Okay. What are your endpoints that your region is? So what should the integral endpoints be? 1 to 4. And then square root of x squared, square root of x. Okay, what about, and then put your dx on it.
My equation? Am I putting?
Whatever the r is, but remember, if you like flip this across, that would be the r. Because remember, you're like reflecting it across the axis.
How do I not putting x squared on it?
No, you just do x squared, because remember, this is the top and the bottom is 0. No or yes? It's okay if it's no. So look, as this spins around, if you were to cut, Mr. Ken, if you were to cut this, that would be your circle, your radius would only be half. So the line that's drawn in there, the top of the line is x squared, the bottom of the line is the x-axis that comes into it.
That's why it's not mine.
That's why it's, because 3 is the side. That's how far over you go. So those are the endpoints.
I know what I'm doing.
I don't know.
I know what I'm
I forgot! I'm sorry. Okay, first one. Where should your integral be between? Where to where? Okay, pi integral 0 to 3. And then if you were to reflect that shape across the x-axis, okay, you would have like a little volcano. Okay, and your radius would only be halfway through that, so from here to here. So you even have a little rectangle radius drawn for you. Then it would be top minus bottom, x squared minus 0. Which means it would just be x squared squared dx. Got it? Okay, other one. What's the integral from? Volume equals? 1 to 4. And then what's my radius? Root x squared dx. Okay, turn over to the back. I'm going to give you one more to do. Number 11.
Wait, can you go back?
I can. Okay, do number 11.
1 second.
That. Okay, set up number 11. Think about where you should shade. Okay, so if you look at your shape, does it ever say only in the first quadrant, or does it not say that? Doesn't say that. So we're doing this whole chunk. Okay, how am I going to find where those intersect one another?
X equals x squared minus 4.
Okay, perfect. But pause for a second. We got to find these endpoints. But you are exactly right. Okay, if I said x squared and 4 equal,
2 and minus 2.
yeah, negative 2 here, positive 2 here. And then when I spin that around the x-axis, okay, my other side would be here, and you would have your little solid like that. Now, when I draw in my radius, I'm going to draw my circle here, and then I want to draw in my radius. I see that it's going to be top minus bottom right there. What is the function that is on top of that radius? Is it the 4 or the x squared?
Negative x.
Don't change any signs. Remember, it's only upside down because it's revolving. So what is this boundary, the curve or the line? Okay, so r of x is x squared minus 4. Now, if you put 4 minus x squared, that's not wrong. Because since it's revolving, think about pi r squared. Does the order matter if you're going to square it? No. So if you got these backwards, you're still right. That's totally fine. If you drew your r in down here, it would come out where 4 is on top and x squared is on bottom. That's totally fine. That's not wrong. Okay? So then it would be volume equals pi integral negative 2 to 2. And then whichever order you put that in, doesn't matter. I'm going to put x squared minus 4 squared dx. So far, so good? Okay, back to your notes. Turn over to the back. We're going to practice these now, dy. Okay, so at the top, it actually says dx. I want you to change that to a dy. We just did dx. You are going to do it dy if you are rotating around the y-axis or another vertical axis of rotation. Okay? If you're going around the y-axis or a vertical axis of rotation, that would be dy, not dx. Fix it right there. Okay, here's how you find your volume. Pi integral r of y squared dy. And then your endpoints aren't going to be x values, they're going to be y values. So I'm going to use c and d. C and d are going to be y values. And how do you guess if it's dy, your radius is going to be?
Oh, right, left.
Right to left. Very good. R of y is going to be right minus left. Okay? Now, another thing, I'm going to put a little star here. Your equations need to be in x equals form. Just like for area, just like for what we did last week, they have to be x equals for you to do dy. Now, if they don't come that way, you can always fix it. Okay? Alright, so let's do this first one. We have x equals negative 2y plus 4. Okay, so let's think about, if I'm graphing this, 1, 2, 3, 4, that's going to be here. And then when you guys are flipping graphs, okay, what I would do is, if I want to know where this hits x equals 0, I'm going to set this equal to 0 to find out. So if I want to find the y-intercept, to find the y-intercept, you're going to let x be 0. And that's going to let you know where it would end up hitting. So if this is a 0, I would add my 2y across. 2y equals 4. Then what? Divide by 2. So y equals 2. That means that this graph hits at 2 right there, and then I can draw my line in. Okay, then it says I want to be bound in the first quadrant. That tells me I'm only shading here to here. Okay, now look at the instructions. It says, find the volume of the solid generated by rotating region R around what? The y-axis. That means that this is going to be your center point, and you're going to spin it around this way. So rather than reflecting it down, I'm going to think about I'm spinning it this way. And so it's going to end up over here. Does that make sense? So what shape is that going to make once I rotate it around? Like a cone, right? And if I slice the cone, what shape would I see in the middle? A circle. And where's the radius of the circle going to be? Right to left. That would be your radius right there. Does that make sense? Okay, now I need to do the right side of the radius minus the left side of the radius. What is the right side touching? The negative 2y plus 4. What's the left side touching? X equals 0. So you do x equals negative 2y plus 4 minus x equals 0. Right minus left on both. Okay? So it'd be negative 2y plus 4 minus 0. Then from there, when I set up my integral, what endpoints am I going to use? Is it going to be 0 to 4?
No. 2 to 4. 0 to 2.
0 to 2. Because what is this? Y equals 2. And what is this? Y equals 0. So remember, when I do an integral dy, I have to let my y values be my endpoint. So v equals pi integral 0 to 2. And then my radius was negative 2y plus 4 squared dy. So it's pi r squared. Because when it revolves, it makes a circle. Just like last week, but we only did semicircles. Make sense? Okay, I'm going to bring you a cookie, and I want you to work out your integral. What method do you need? U sub.
When you use sub, do you still do u, du, dx equals y?
You do u du and get dy. Yeah? Okay, so I'll come give you a little treat. Okay, see if you can figure it out.
The top one would be 0.
You guys want a cookie?
Even though that I understand this is just cost.
It's not.
Yeah, or that merely off.
Are you gonna give it to Chew? No, I don't care. Is it you that always is sneaking him cookies?
What's 4 cubed?
Just put 4 cubed. It is 64 though, but if you didn't know, you could just put 4 cubed. Go. Y'all getting it?
Is it 64 pi over 6?
It is.
Hell yeah.
Good job.
Why do you think that? Just hurry. No. Is the pi over 6 supposed to be negative?
It is, but when you subtract, you end up with 0 minus 64, which comes out negative, and then it'll cross out with the negative. Okay, so your u was negative 2y plus 4. du is negative 2 dy.
64 pi over 6.
So I'm going to put my negative 2 out in front, and then that's...
Do you sub?
And do you plug in your endpoints?
Did you do u to the cube?
Like I got 64, but then I don't know where you got the 6 from.
Oh, okay, watch. We're about to get this. So you had the pi halves in the front, right? Okay, so when you plug in here, negative 2 times 2 plus 4 is 0. Other one is 4. When you integrate this, what's the integral of u squared?
U cubed.
U cubed, and then what do you have to do with the 3? 1/3 times the pi over 2.
We had already integrated one.
We just rewrote it.
Okay.
So it went from squared to still squared. So then at that point, you would plug in,
That's the only thing
yeah, your 0 and then your 4. 0 cubed is still 0, 4 cubed is 64, but then here's where the negative goes away. When you do 0 minus 64, that comes out to be a negative, and that's going to cross out with that negative. Okay? So you would end up with negative pi over 6 because of the 2 times 3, and then times negative 64 becomes 64 pi over 6. Now, you could reduce that, or you could not. It doesn't matter. Okay? All right, next one. Sketch your graph. Yes?
I'm not playing Helen.
Oh,
We're
okay.
gossiping.
About math.
Totally.
Okay, first quadrant, x squared, that'd be here. The y-axis, so that's this one here. And then y equals 9, that would be here. shade the side of your graph that you want. If we want to be in the first quadrant, we have to be on this side. Now, what are we rotating that around, it says? Rotating the region around the y-axis that's here. So if I take that region and I spin it around this way, you already, if you drew the whole parabola, you already have the other side. And then if I were to go in and draw my cross section, okay, cutting across this way, you can see it would be a circle because it's rotating around. Your radius would be right here in the middle of the circle. And then remember, your radius would be the right side minus the left side. Now question, I'm going to point at something, tell me if we're good so far. Okay, we need y values.
No.
Right minus left. But what are our equations supposed to be? X equals form. How is this equation written? Y equals x squared. We can't use that. So if it's y equals x squared, how am I going to fix that? Square root, and I'm going to call it x equals square root y for that side. Because remember, it can't be in y equals form or else you can't use it.
Plug 9 in.
Okay, you don't have to plug 9 in because we already know y is 9. It already gave you a y value.
What was that?
So it would be root y minus 0. And then remember, guys, that the other side is a minus 0 because it's the y-axis. That counts as x equals 0. So it would be root y on this side and then 0 on this side. So then volume equals, write your integral, don't say it out loud. Okay, think about your endpoints. Your endpoints should be y values, and you should do pi r squared. Okay, 0 to 9. Yep, that's okay. And then we want our radius squared, which is root y squared dy. And we're not going to work that one out, but hopefully you could.
Wouldn't it just be y?
You wouldn't need u sub. If it's root y squared, that'd just be y. And then you could do it normal. Okay? Good. Okay, so that would simplify, and then you can do it from there. Okay, number 7, set it up. Okay, this is the last one we're doing today. Okay? So you have this guy, x equals 8, y equals 2. Which way is y equals root x minus 8 going to be shifted?
To the right.
Correct. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there it is. Then we want x equals 8. That would be here. And then we want y equals 2. That would be here. So my region would be this kind of like little triangle thingy, like that. Okay, what does it say we're revolving around? X equals 8. Okay, now this is important. If your x-axis and y-axis are way over here, is either one of your sides going to be 0? No, you're not over by the x-axis or the y-axis. So draw in the other half of your shape. It's rotating around this way. And you would have kind of like almost like a little volcano. Okay? Or not a volcano, a tornado. And it's like whoosh, spinning around. Okay? No pun intended. Volcano. Or wait, tornado. Spinning. Get it? Okay. There's your circle. Your radius is only half of it. What would right minus left be, or do I need to fix my equations? Gotta fix them. We can't use y equals. So if y is the square root of x minus 8, I would have to square both sides. Squared and square root cross each other out. So y squared is x minus 8. Then what would I do with the minus 8? Add it across. So this side is going to be x equals y squared plus 8. Now, if you draw the other half of that parabola, does it make sense that it starts at 8 and it opens to the right?
Yes.
Okay, that's the exact same graph. Okay? So, from there, when I do right minus left, what's the right side? Y squared plus 8. What's the left side? X equals 8. And when I subtract those, what's going to happen?
Y squared.
Very good. So your radius, one more time in case you got lost, is going to be the right side, which is y squared plus 8, minus the left side, which is x equals 8. And then those 8s are going to cross each other out and make your r of y only the y squared. Then from there, remember volume equals pi integral where to where for my integral? Good, you're using the y values, that's 0, that's 2. And then your equation is y squared quantity squared dy. So really, if you were going to work that out by hand, what would you make the power on y? Y to the 4th.
Then I do U sub?
You would not need u sub, correct. So it would be like that. Okay? Okay, I would like for you to at least set up number 12 off your homework. These are the only two where one of the sides is in the x or the y axis. So set up number 12 for me. Okay, that's the last question on your homework. Number 12. What does y equals x look like? Okay. Now, should I call it y equals x? If I'm going to rotate around x equals 6, that's vertical, I'm going to do this dy. So how could I call that instead? X equals y. But remember, y equals x would be for dx, but since we want it in a dy form, it has to be x equals. Okay, then I want x equals 6, that's here. And then my other side is y equals 0. Which axis is that? The horizontal one, so that would be here. Now, that's your region, but you have to think about what you're rotating around. What does it say we're going to rotate about? X equals 6. That's this side. So draw your axis of revolution right there. And I'm going to spin this shape around that axis, okay, so that the other side is going to come up over on that side. And remember, it's rotating around like that. Okay? Draw in your radius. Now, this is where it gets tricky. Okay, some of y'all might get confused even though it's not supposed to be. You can draw your radius on this side or on this side. It doesn't matter. I'm going to draw mine here, but if you drew yours there, you're not wrong. Right minus left for me, based on where I drew it, is going to be what?
6.
6 is on the right, y is on the left. But if you put it backwards, remember, it's pi r squared, so it doesn't matter. So volume equals pi integral 6 minus y squared dy. The last other thing that we have to find is the y values on your graph. Now, think about the bottom y value. How low is it? 0. If this is 6, x is 6, what is the y value? 6. Yeah, because what does it say about y and x? They have to be equal. So if x is 6, that means y is 6. So then I would make it 0 to 6. Got it? Okay, listen, it's going to get a baby tiny step harder on Wednesday. So I need you to make sure that you on Wednesday know how to do it like this. So it can get just a little bit harder. Okay? And you have a free day.